Hey everyone, I hope you all are safe and doing good. So in the series of learning Python programming language, we have completed our inheritance concept in Python. What is inheritance and types of inheritance we have discussed, right? But one thing is still remaining in this inheritance. We have a diamond problem in inheritance, classic diamond problem, especially in multiple inheritance. Now that thing we'll discuss in this video. What is this problem, diamond problem? Why this occur? Right? And how to solve this problem? Which method Python used to solve this problem? What is MRO, method resolution order? Which algorithm the MRO use to find out the order, like C3 Linearization Algorithm, right? So in detail we will see that algorithm as well, right? It's not like that simply on your laptop you can just use the attribute, this attribute underscore MRO underscore or maybe MRO function. So you will get the MRO, but how you are getting that MRO? What is behind the scene? What is the algorithm, the working? That also step by step I'll show you, right? Okay, now let's see first of all, what is this classic diamond problem? See, this thing we have seen, this is hybrid inheritance, right? This is what? Hierarchical, and this is what? Multiple inheritance. So this is basically this type of structure. As you can see, it is somewhat like a diamond, right? And here, what is this problem? If suppose I am having same method, like maybe show in this parent method and as well as show in this child also, and this child one has overridden this method, right? And suppose show in this child 2 as well, and this also has overridden this method. Now this child 3 is inheriting from child 1 as well as from child 2. These two are parent of child 3. So child 3 would be confused. Which method it will inherit? Using the object of child 3, which method should be called? This method or this method? Or the parent method? Because ultimately this is, we can say, like maybe grandfather type of thing, right? So from there also it is inheriting. Right? So now child 3 is in confusion. Which method it is going to call or inherit, this or this, if they have overridden this method. If they are not having any show method, so it will inherit from show here. Right? Fine? Okay, now to solve this problem, in Python it is not a big problem. Basically we use MRO, method resolution order, to solve this problem. Right? Now what is this MRO? It is just a method, or you can say, to get the order in which the derived class will inherit or will call the attributes and methods from the base classes, or you can say from the hierarchy of classes. In which order the derived class is going to inherit, if it is inheriting from multiple classes, right? Let's suppose if in my class I just give an assignment, right, and I asked all the students to submit that assignment tomorrow only. So on the next day everyone is ready with their assignment, right? And if everyone like comes to me, ma'am, my assignment, then it would be very hectic for me. Like from whom I'm going to accept the assignment first, because everyone is present here, right? To solve this problem, like the order, to solve this problem, what I can say, like I'll say please be seated at where you are at your seats, and I'll call your roll number, and according to that you will come and submit your assignment. Means first I'll say roll number 1, roll number 1 will come and submit his or her assignment, then roll number 2, then roll number 3, roll number 4, like this. So I have used the roll number technique, the method, right, to solve this problem. Fine. Same kind of thing in programming, because assignment is, like you can say, it's same method or same attribute I'm going to access from all the students, right? So same method is in all the parent, and so the derived class, this child class, will access method from which parent. To solve this problem, this is basically, this confusion is classic diamond problem. And because of the shape, it is diamond like, that is why it is known as diamond problem. And this is an interview question as well. But in some languages, like in Java, Java don't support multiple inheritance because of this problem only. They use that interfaces concept, right? But in Python, it could be resolved easily with the help of this technique MRO, right? Now, I told you MRO is what? MRO is used to get the order in which the methods or attributes are to be inherited from the hierarchy of classes in case of multiple inheritance, because this problem especially arises when we use multiple inheritance in your program, right? Okay, now let me just show you practically this thing, this class, and how MRO is going to solve this problem, right? And then we will discuss right now the default algorithm which is used to solve this problem in this MRO. In this MRO use C3 Linearization Algorithm to get MRO. Now, what is this algorithm and how we are going to get this thing, that also I'll show you, right? Let's see practically. Okay, so let's create a new file here, diamondproblem.py, right? And let's take this example only. We have class A having display function display from A class. Class B, it is inheriting from A class. Class C as well, suppose inheriting, let's just modify a little bit, from A class, right? It is having display and it is having show, as well as let's say it is having display. Show is going to show like hi from C class, and display from, sorry, not B class, it's from C class. Now class D is hiring from both B and C, and suppose it is not having any display function. So let's just write down here pass. Okay, now with the help of this D1 object, I want to call display function. So which display it is going to call, from B or from C? Because both are parent of this class, this what we can say D class, right? So this problem can be solved in Python with the help of MRO, method resolution model. So it will first search what is the first parent is B. So it will search in, first of all it will search in B. We are not having any method display in B, so it will search the first parent is B. So it will search in B. In B we are having display, yes, so it will access, it will inherit this display, right? That's it. So let's run this. So display from B class, it is inheriting from B class only. And suppose I'm not having this display in B class, in that case pass. Now first it will search in B, there is no display, then it will search in C. It will not go deeper, it will not go in the parent of P, no. The latest technique is C3 linearization, that is what it follows, left to right first, then go deeper. And previously deeper means depth first, then left to right, right? So if I run this, then it will display from C class, right? In B we are not having, in the first parent we are not having display, then in search in C. If in C as well I am not having, then left to right there is no display, then it will go deeper. Deeper means the superclass of this B and C. Superclass is A. Now it will go to A. C, display from A class, right? So with the help of MRO you can solve this problem. So if you want to print the MRO of this class for D class, then with the help of this function or with the help of attribute, we are having this attribute as well as like this field MRO. With the help of this attribute also you can print the MRO. See, first D, then B, then C, then A, then object class, right? O class or object class. Let's take a complex example and then I'll show you step by step what is going on behind the scene, how we are getting this MRO like this, what are the steps of this algorithm, what is the C3 linearization algorithm, right? Step by step I'm going to show you with the help of a complex example. I hope you will get it, right? So if you want to go deeper, if you want to understand what is the behind the scene process of this MRO, the algorithm, the steps of that algorithm, then you can continue to watch this video. Otherwise for you that's it, right? Okay, let's take this example. I'm having class A, B, C, D, E, and F class is deriving from A, B, C, then G class is inheriting from D, B, E, then H class from DA, and then finally Z class from F, G and H, right? So if it is having, obviously multiple inheritance and many type of inheritance, so if you want to access some method with the help of this object of this Z class, then what is the MRO, the method resolution order? First, in which class it is going to search, then this, then this. Then obviously with the help of MRO attribute or MRO function, you can easily find out. But what is behind the scene? What is the algorithm? The steps, right? Please don't write down in comment section like the syntax is correct and there should be colon, then pass, colon, pass. Okay. Now let's just draw first a diagram of this thing. So I'm just starting from here. The last class is Z. So Z is inheriting from F, G and H. So this order is also very important. This is one known as local precedence order, right? And the algorithm or the technique you use to find out MRO, that should follow this local precedence. Means first, if with the help of object of Z class you want to access something, then first it will search in this order, in this declaration order, F, then G, then H. This is local precedence order, right? Second thing which is important that should follow by the algorithm which is used to find out MRO is what? Monotonicity. Now what is monotonicity? See, if the class, we have a class C and base class of C is C1 and base class of C1 is C2. So if you find out the MRO of C, the method, then it would be first it will search in C, then in C1, then in C2, something like this. So if this C1 class is before C2 class, then you are going to find out the precedence order or the MRO of C. If C1 precedes C2 while finding the MRO of C, then definitely C1 precedes C2 if you want to find out MRO of any subclass of this C. If you have any subclass of C like Z, and if you want to find out the Z MRO of Z, then definitely it would be Z, then C, then C1, then C2. C1 is before C2 in this also, in this also. This is type of monotonicity. It's not like that for Z, first C2, then C1. It will create problem, right? So I hope now you got what is local precedence order and what is monotonicity. So these two rules should be followed by the algorithm which is used to find out the MRO, and which algorithm is used by default in Python 3 is C3 linearization, right? Now what is this algorithm? I'll tell you and how this is different from what was used before Python 2.3, an old style technique to find out MRO that caused many problems, right? So we have first Z. Now Z, F, G, H. So in this order only I'll write in the diagram as well, F, G and H. Not like H, G, F, something like this, right? Then for F, A, B, C. So A, B, C. F is hiring from A, B, C, left to right in this order. Then G is hiring from D, B, E. So B, after B we are having E. So let's suppose here we are having E, and before D is before B. So let's write down D here. So D, B, E. Then for H, D, A. So D and A. That's it. Or one more thing, because we know object class, or simply you can write down here O. It is root for all the classes by default in Python 3, right? So you can write down something like this, like here object, or simply O. Or if you don't write, that is also fine. Automatically it will inherit from object class, right? Now this is the diagrammatic representation. Now how to find out MRO of Z? What is that C3 linearization algorithm? How to find out? Let's see the steps. If you find out linearization of Z, then please watch carefully. Then Z plus the name of that class plus merge function we are going to use in this C3 linearization algorithm, right? Merge, then linearization of all the super classes of this Z. Then linearization of L means linearization of superclass of Z is what? F, G, H. So F, comma, G, comma, H. And then list of superclasses F, G, H in the same order in which we have written like F, G, H here, right? Okay. Now, obviously, we have to find out first linearization of F. Linearization of F. So first find out this F. Same technique, write down F plus merge of linearization of all the base classes of F. Base classes of F. It's A, B, C. It's A, B and C. Right? And just write down list of all the base classes A, B, C. Okay. Now linearization of A. Okay, now linearization of A is what? Means with the help of A object, if you want to access the method, then from first it will search in A, then in its base class. So base class of A is object class only, right? So from diagram only we can just find out L of A is what? AO. No need to write down in this form. Or if you want to write down, then you can just write down like L of A is equal to A plus merge linearization of O and O. Both are object, so it would be O only. Sorry. O only. So it would be A and O. That's it. Right? Okay. So just write down here F plus merge L of A is AO, L of B is obviously BO, then CO and then ABC. Now we have these list of linearization of A, then this list, this list, this list. I'm not writing down like this particular list, okay, but these are list. Fine. Now how this merge function works? So first of all, take the first list and mark the first element of the list as head. So A is what? Head. First step is this. Second step is you have to find out it is a good head or not. Now how to find out? If this A, see, this A is head and whatever after this A, that is tail of the list. Here only O, so this is tail of the list. Here B is head, this is tail. C is head, this is tail. A is head, BC tail. BC both are tail. Not like only C is tail. No. Except head, except the first element, all the elements are tail. If there are 3, 4, 5 elements, right? So now A is head. Second step is if the head is present in the tail of any other list, then it is not a good head and we cannot take it. So here A is marked as head. Is it present in the tail of any other list? No. So it is not present. Means it is a good head. Okay. Now head we have gotten A is head. Now if it is a good head, third step is if it is a good head, then just you have to add this here in the MRO of that class. Like first was F, then add to this MRO. That was at the beginning of this line. FA plus. And remove this from all the list. So remove this A, here O, BO, CO and BC only. Okay. Now, if you have done this, it's okay. Then take the second element and same step. If it is not a good head, suppose A was not a good head, in that case what you will do? Next step is switch to the next list, mark the first element as head and same process you have to repeat. Check if it is in the tail of the other list, right? If it is present, then it is not a good head, then switch to next list, and like this, right? Okay, now like this. Now next is O. Check, O is present in the tail of other list, yes, O, so it is not a good head, so switch to next list. First element is B, so mark it as head. Is it present in the tail of other list? No, so B is good head. If it is good head, just remove this and add here in the MRO, FAB plus, as well as remove this B from all the list, O, C, O, C. B was done. Now next is O. Is it the tail of other list? Yes. So it is not a good head. Move to the next list, C. Now C is present in the tail of other list? No. So let's consider C is a good head. So FABC plus merge OOO. And this is what object, so that is why merge of this O is O only. So finally FABCO. This is linearization of F class. FABCO. Right? Okay. Now if you got this, then you have to find out linearization of G and H. It is up to you. Same step you have to repeat for G and H, right? I'm directly write down the algorithm, the linearization of G and H, because finally we will find out this Z. If you haven't got this thing, you can pause the video, you can rewind the video, you can watch this again, right? Okay. Okay, so this is linearization of F, the list. This is for G, this is for H. I hope you got this one correct, right? Okay, now you have to find out for Z. So Z plus, take the first list, consider F as H head. Now find out F is in the tail of other list. Tail of this list is this one, DBEO, DAO. For this GH, is it present in the tail of other list? No. So Z F plus, just remove this from everywhere. So F A B C O, then Z G D B E O, H D A O, and remove this F as well as G H. Now this is remaining. Take the next element A, mark it as head. Now check if it is present in the tail of other list. Tail of this list is no. Yes, D A O. It is present in the tail of this list. So it is not a good head. So we cannot take this. If it is not a good head, then jump to the next list and consider G as head. Now G is present in the tail of other list? No. So yes, G is good head. So just add G here in the MRO of Z and remove this G from the list. H, D, A, O, and here we have now H only, right? Now G was done. Now next is D. So is D present in the tail of other list? Yes, D. So D is not a good head. Okay, switch to the next list. Now consider H as head. Is it present in the tail of other list? No. So it is good head. So Z F G H plus merge A B C O, then remove H D A O, right? Now next is D. Now D is present in the tail of other list? B E O, B C O, no. So D is good head. Z F G H D plus merge A B C O, just remove this D, B E O and A O. Now next is D we have removed. After H it was D. Now next is A. Is A present in the tail of other list? E O, B C O, no. So take this A as well as D, A, and remove this from there. Remove this from A here also. A is here. So B C O, B E O and O. From every list you have to remove that element that was head and removed from here. Now after A it is O. O is present in the tail of other list? Yes. Now move to the next list. Next is BCO, back. Now take B. Is B present in the tail of other list? No. So B is good head. So remove this. See, B is present here, but it is head. I have told you the first element is head. Other than first, every element is tail. So EO is tail. So just remove this CO, EO and O. Now after B we have C. From here we were taken like B, then C. Is C in the tail of other list? No. So Z, same thing you have to repeat. Now C plus merge O, EO and O. Next is O. O is in the tail of other list? Yes. Move to the next list, E. Yes, you can take E, and after E definitely O, so that would be O. So finally we will get Z, F, G, H, D, A, B, C, then E, then O. This is the MRO for Z in this diagram with the help of this C3 linearization technique, which is by default in Python. Which is by default is used in Python 3, right? So see, if you see from this diagram, then this is Z, F, G, H, D, A, B, C, E, O. So it is left to right, then in deep we are going. So this technique use this thing, the new one, this algorithm. First go left to right, then if it is not present in any of the class from left to right, then go deeper. Right? But in old style, the technique was first depth first, then left to right. In older technique, the problem was if I have something like this, A, B, C, let me just take a simple example, D. So if you want to find out MRO of D, then it would be D, then B, then not left to right, first deeper, we will go parent of B, that is A. Then finally, if you consider O, then you can consider O, here O, but I am not considering here O, object class. Then C, then A. Then A are 2 times, so in old style just remove this one, right? And after that a new style was also introduced. There it was, if this is the case, then remove this one, first one, so D, B, C, A. But this also, you know, having some problem. That is why a new technique was introduced, that is C3 linearization algorithm, and that follows these things like monotonicity rule and local precedence order while finding out the MRO. But there are still many things left about MRO, method resolution order, right? It's very, you can say, vast concept. But if you want to go in deep, you can just go to Google and you can find out different examples and many things. That is why I have here taken a complex example, so that you can get this algorithm, the steps of this algorithm, you know, clearly. I hope you got this. I have tried my best, right? So this is all about diamond problem, how to solve this problem in Python, and the C3 linearization technique and all, right? So now I'll see you in the next video. Till then, bye-bye.